Another variant on photosynthesis besides C4 photosynthesis is what we call crassulacean acid metabolism, or CAM. Now, crassulacean acid metabolism, CAM, is a photosynthetic pathway that enables plants to gain carbon under extremely dry conditions. Whereas C4 photosynthesis was predominant in places that were very hot and very bright, C4 photosynthesis provides a water savings, but it isn't primarily an adaptation to low water availability as much as it is high light and high temperatures. CAM, on the other hand, is associated with the driest environments there are and really is there to provide the most water savings possible. The general idea behind CAM photosynthesis is that plants hold their breath during times when they're going to lose the most water, and they have exchange of gases during the times when they would lose the least amount of water. So holding your breath during the day helps you lose less water than during the night. So here's a diagram we had looked at part of it before, showing C3 plants and C3 photosynthesis occurring in the mesophyll cells, C4 plants with the initial fixation of carbon in the mesophyll cells, and then the bundle sheaths having high CO2 concentrations in C3 photosynthesis. CAM plants do something a little bit different. During the daytime, there's decarboxylation of a C4 acid, and that CO2 then gets fixed via normal C3 photosynthesis, and then you have an export of sugar. So this is when normal photosynthesis occurs during the day. And you have decarboxylation just like you do in C4 photosynthesis, except that's happening within the mesophyll cells. And if you look, there's no exchange of CO2 or water. With CAM plants, they keep their stomata closed during the day. During the night, they open their stomata. CO2 comes in, water leaves, but because it's nighttime, it tends to be colder and slightly higher humidity. And so the loss of H2O is a lot less at night than it is during the day. The CO2 that enters the plant during the night in CAM photosynthesis is fixed with through C4 photosynthesis into a C4 acid. And that C4 acid accumulates during the night until it's daytime, and then you start to get light or radiance on the plant. There's decarboxylation and photosynthesis that occurs. So C4 plants, we have a spatial separation of C4 and C3 photosynthesis with gas exchange during the day. At night, well, for CAM plants, there's a temporal separation of C3 and C4 photosynthesis, C3 during the day, C4 at night, and gas exchange happens at night instead of during the day. So, CAM plants have C4 photosynthesis, just like the quote-unquote typical C4 plants. And they also use PEP carboxylase to fix carbon, just like the C4 plants do. And I didn't mention PEP carboxylase too much with C4 plants directly, but it's just as important in CAM plants as it is C4. The main difference between CAM and C4 has to do with temporal versus spatial separation within leaves. So CAM, there's a temporal separation of C4 and C3. For leaves in C4, you have spatial separation, mesophyll and bundle sheath. Now CAM is an adaptation to drought, and it really minimizes how much water is lost per unit gain of CO2. And by doing this, it's able to extend photosynthesis temporally and spatially into drier times and drier places.